Hi and welcome to the 8 days online training program on Google Earth Engine for remote sensing analysis. Already we complete our first, second and third number of lecture. So this is our fourth number of lecture. Okay. So I am a course coordinator and all of the information of my Google Engine 8 days online training course. Already I mentioned all of the course content or course item. So that's why I skip this part. Okay. So now I am going to our fourth day course item. Okay. So in our fourth day course item, we will focus how to remove haze particle or cloud particle from satellite imagery. That means how you can easily apply this technique for pre-processing your satellite images. Okay, if your study area is very a large amount of water body available, large amount of evaporation available, you cannot find less than 1% or 10% or 5% images. That's why we apply this technique. How you can easily remove haze particle or cloud particle from satellite imagery. Okay, so then we apply this technique. Then we visualization, we learn visualization dem data, that means digital elevation model data, or hill shade, slope map, aspect map. Okay, in Google Earth Engine platform by using NASA SRTM, and also lot of um, another dataset available in Google Earth Engine platform. So in this lecture, we focus NASA SRTM dataset. Okay, so that means we handle digital elevation model DEM dataset and make hillshade map, slope map, aspect map using Google Earth Engine platform using NASA SRTM dataset. Okay, so then we focus how you can easily export this reflectance, and another is top atmospheric reflectance. Okay, suppose randomly we select one the top atmospheric reflectance. So in this time you see here that this harmonized Sentinel-2 MSI, that means multi-spectral instrument level 1C dataset available time year of 2015 to year of 2024, 15th August. Okay, so this is the update time. So dataset available time start from year 2015. This dataset provided European Union ESA Copernicus. Okay, so this is our Google Earth Engine snapshot. Okay, we simply copy in and paste in our code editor for importing. Okay, all of the description of the dataset you see here. When you read it, you learn all of the things. So here you see the band combination for this Landsat Sentinel 2 data set. B1, okay, B1 band indicate the aerosol band, B2 indicate the blue band, B3 indicate the green band. Already we discuss, okay, all of the things in our maybe second lecture. Okay, so I simply copy this Google Earth in snippet. Okay, Earth in simply copy and paste in our code editor, and take a variable or set a variable name is suppose sentinel. Okay, if you want, suppose we take a variable name is suppose sentinel. Okay, sentinel 2. Okay, Sentinel 2 we select as a variable name of this Sentinel 2 that top atmospheric reflectance data set. So now we filter step by step. Okay, so wait a minute. So suppose after that we any study area input any study area from our asset. Suppose we apply. Suppose we simply use here the okay any study area, we use the Dhaka district shapefile for a for example. Okay, suppose randomly we select this study area for our this analysis purpose. Wait a minute, maybe networking issue. Okay, so simply click the import, automatically stored in. Okay, already we import in our code editor. So okay, so suppose suppose we simply uh, we first of all we take a variable name is suppose image. Okay, you can use any variable name, no problem. And then call this our total sentinel 2 data set image collection. Okay, stored in the variable name sentinel 2. Okay, so simply copy and paste here. Okay, so paste here. Then we use here the as well as filter bounds function for select our only our specific study area. Suppose this study area we select here the variable name is AOI, area of interest. You can use any variable name, no problem. So simply paste here. And how now if you want to check how many images are available in your study area. Okay, simply copy this filtered variable name and paste here, and use here the size function for show as a round figure number or integer number. So when you click the run, number is computing. After some time, we will okay 1650 images are available for our this study area. Okay, so now we filter step by step. Suppose we take your filter our specific time frame. Wait a minute. Suppose we filter our specific time frame, filter date function, and start date and end date. Suppose start date we select from the data set, start the year of 2015 to present time. So that's why we use here the this time frame between okay, suppose we randomly select the year of 2016. Okay, 2016 1st January. Wait a minute. 1st January to year of 2000 suppose 16 31st December. Okay, for total 1 year we filter and check how many images available for our this is a specific time frame. Okay, and it's with our specific stuff. Okay, only 96 images. Okay, 96 images available in our study area. Now if we if we use the filter, suppose we filter our metadata from this data set, filter metadata. Okay, so filter metadata, here you see the image properties, cloudy pixel percentage is our filter metadata. Okay, this is the image properties band name is cloudy pixel images. Here is a description is a specific cloudy pixel. Okay, is cloudy pixel percentage taken from the original metadata. So we use this cloudy pixel percentage, simply copy and make here this function. So suppose we use the filter function, and suppose if you want to check, okay, wait a minute, after some time we will learn all of the things. Okay, we use the e dot filter. Okay, e dot filter we access here less than, suppose less than 90%. Okay, suppose less than now, filter dot, use the dot function. Okay, now our code is working. So we simply copy this QA60 band, and now we call our this function variable name or element name is image, and use the select function and select this QA60 band. Okay, that means we take a function and function variable name, sorry, QA60 band. Wait a minute, we copy again QA60 band and paste here. Okay, we select here from this sentinel data set, we select here the QA60 band. Okay, that's why we use, suppose we, for better understanding, we take a variable name QA. You can use any variable name, no problem. So we use the QA, then we call this function already we develop here. Okay, so now we same again we call this. Okay, again we call this our filtered images. Wait a minute, again we call this our filtered images, and all of the things same. And now with this function attached in our filtered here. That's why we use here the map function. Okay, wait a minute. After some we learn it. Make map function and call our this band we apply band 4, band 3, and band 2. Okay, so now it is 98% or 100% for better visualization, and apply and import in our code editor, automatically import in our new line as our code this param 2. Okay, so simply copy this param 2 and paste here image cloud 50 layer and set as a layer name is then suppose cloud free image. If you want, you can use any set any variable name. No, it's not a big deal. Okay, so now you see in our layer, one layer is this is a cloud free image, and another layer is cloudy image. When you zoom this layer, here you see this layer have lots of haze particle or cloud particle as a whitish shadow. Okay, all of the things. When you zoom it, you see here. Wait a minute. So all of the whitish shadow or white particle show as a haze particle or cloud particle. And now you see the layer 2. Wait a minute, after loading, you see easily. Okay. So layer 2 show as a good images for analysis. Okay, is this white AO? This whitish area not here, not haze particle is show as a build-up area in our Dhaka city. Okay, build-up area. So now you see here this difference between these two images. Okay, after this is our after removing all of the haze particle, and this is our before removing of haze or cloud pixel. Okay, if you see as a good for a good, okay, if you change this time frame, wait a minute, suppose 01 not 1, okay, suppose we use the 30 7, simply copy just for better visualization. We set the different time frame and apply 0 value for okay. Okay, so in this time you see the lots of haze particle available in this images. Okay, so when we set the one layer, that means we make a median composite image for better visualization. Already we set. Okay, we use at the 1 year. Okay, so no problem. It's just for example. Copy this date frame, time frame, and paste here. Okay, look the run. So now we see same thing we see here again. So this is a has containing images or cloud pixel containing images, and this is our after uh, removing this haze or this cloud pixel images, we see it. Okay, so this is the way. Okay, or this is the way for if you want, if you want how you can easily remove the all of the haze particle or cloud pixel from this from your specific uh, satellite images. You can easily apply it. Okay, now if you want to export these images, just to use the export function, export dot image to drive. Okay, export dot image to drive, apply these things all. Okay, image to drive, D is capital, image to drive, and all of the argument step by step we step by put here. Suppose this what is our image. image is our, this is our final filter. This image is image cloud free. This is variable name. Then description name you can use anything. Then we use the folder name, and file name prefix dimension not needed, less important. Then region is needed. Then we put here the region. Then scale needed. CRS transform, CRS not needed. Max within needed. Then we step by step we put all of the things, uh, all of the things, and export these images in your Google Drive. Okay, these things we need to export. That's why we put here. Okay, it's your assignment. Export uh, cloud free image from your study area. I will send you this practice code. No problem. Okay. So if you have any question about this, anyone can ask me. No problem. So if I go to my presentation slide, already we see, you see here. So this is already we apply this way. Okay, here you see the how to remove cloud pixel from satellite imagery. This is the one is fresh images. This is another is hash containing image. Okay,
I had one clarification from the earlier.
this code.
Yeah, Mr.
Okay,
Rahman.
okay.
Uh, First, before I forget, regarding that time series chart you were showing, we had also the remaining part of from
Third class, right?
NDVI map. Yeah, I remember that NDVI some was remaining. Anyway, this may solve it, the same thing. It may
Okay,
be of similar thing.
okay.
My doubt is now again when you did the function of function when we use the uh, function of the image that cloud var cloud 2 mask,
Yeah,
and the last final our our final was okay, the same function cloud 2 mask.
yeah.
This and the earlier filter image, we haven't linked together this whatever we have masked. Did we link this with this filter image?
This one.
Yeah, yeah.
Okay, just for I said here the two things because one is a raw images and one is after when we apply this way, then we see it. That's why we I put here the two layer. Okay, if you want, just you remove one thing. Suppose if you want, you remove it, no problem. Just you see as a one layer. Okay, okay, click the run. So now you see as a one layer, as a this is already we this when we make when we um, apply this function for removing all of the allowed, just we see here the one layer. Okay, for we did difference between these raw images and this applied function images. That's why we I put here these things. Okay.
No, it's okay. Thank you. That is, thank you for the clarification. No, what I mean to say is,
Yeah.
uh, if you look into that function area, we have put that var name as cloud. Can you go a little up? Yeah, cloud 2 mask.
Cloud to
Okay.
marks. Okay.
This is the final image we have got it from masking all those cloud, that
No, no, no.
variables that we have put.
Okay, dear. Just we apply this function for removing all of the haze. Okay.
Haze, right? Correct. Right.
Just we
Okay.
apply and with
Now, how have
yeah. Okay.
where did we connect this cloud to mask in the lower when you continue this syntax down there?
Lower
Where
part.
have we connect? Ah, okay, okay,
Okay.
cloud to mask.
So
That is
this
what I was
function,
thinking.
okay,
Thank you.
this function attached in our these filtered images. Okay,
Yeah, yeah, yeah.
that's
Okay,
why
okay,
it's
yeah.
working in our map
Understand.
interactive view.
Yeah, that's why it's working. Correct.
Okay.
Yeah, thank you, thank you.
Okay, okay. So it's just when we make every function, okay, when we make every function, we must be must be put in our main filtered images and see our map interactive view. Okay, okay. So no problem. So now I am going to my new code editor, and we discuss about our land surface temperature monitoring. Okay, okay.